All right, so here we're dealing with polynomial functions that are in this form here. So f of x equals some coefficient a times x to the n power. So n could be 0, 1, 2, 3, 4, 5, right? Any whole number we just talked about. So specifically here, what we're going to look at is we're going to look at when a is positive, right? I've got a positive 1 in front of all of these, so a is positive, and n is an even number, right? 2, 4, 8, those are all even numbers. So we're going to say that a is positive and n is even. All right, now in these scenarios, you can kind of take a look at the graphs and see that look at the red, the blue, and the green, and you can kind of notice a few things off the bat. First thing we're going to talk about here is end behavior. Now for end behavior, what we do is we say that as x goes to negative infinity, we're wondering what f of x does. All right, and that's how we do these arrows. And then I'm going to say that when x goes to positive infinity, I really want to know what happens to f of x as well. Remember, f of x is my y values. So this is my left and right x values. This is my up and down y values. So as x goes to negative infinity, in other words, as I go to the left, what is happening to the height of this? What is happening to my y values? Well, no matter if I'm on the red path, the blue path, or the green path, as I go to the left, right, as I go to negative infinity to the left, my y values are going up. So up, well, down would be negative infinity down here, right, negative infinity. We are going up to positive infinity. All right, so again, as I go to the left, as x goes to negative infinity to the left, my y values go up, right, up to positive infinity. And then as x goes to positive infinity off to the right, that's what this means, as x goes to infinity, my y values, well, they also go up to positive infinity, right? So as my x values go to the right, my y values go up. And up, we know, is infinity, right? So how we would say this is read as, I'm going to zoom in here, so hopefully you have enough room to write this. As x goes to negative infinity, f of x goes to positive infinity. That's how we would read this, all right? That's how you use your words to describe what you see here in that notation there, all right? So again, as x goes to negative infinity, y goes to positive infinity, all right? That describes the end behavior. Now, another way to think about this, and if we want to like use kind of some basic terms, aka as I go left, right, negative infinity for the x values is to the left, the graph goes up, right? My y values would go to positive infinity. So that's another way to kind of think of it just in simple terms. As I go left, the graph goes up. So as x goes to negative infinity, f of x goes to positive infinity. That's just kind of a simple way to think about it. All right. So that would be my end behavior. What you'll typically see is you'll actually see this written on the graph a lot of times. So up here, you'll see as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity to the right, my y values go up forever to positive infinity. So you'll typically see it written on the graph like that. Now the shape. First thing we know is that it opens upwards. All right, if we remember anything from quadratics, we know this is because a is positive, right? That number in front of my x squared term is positive, or in front of the x to the fourth or x to the eighth, right? As long as a is positive, it's going to have that open up curve. What we also kind of noticed, now this is not always true for all of these polynomials, but specifically when you just have a times x to the n power, this is typically true, is that you'll notice that the higher the degree, the flatter it gets, right? If I look at my y equals x squared, that's the red. The red is, pretty smooth. It's not super boxy. But then if I look at y equals x to the eighth, that is kind of more of a boxy shape. So it kind of flattens out towards that x-axis there. So just something that you might notice when we have these in the form ax to the n power. Now that doesn't always mean that these are really flat shapes. If I add, 3x to the 7th plus x to the, if I add a bunch of stuff after it, it'll mess up that shape and it'll change. It won't be as flat as you see here. This is really just for when we're talking about this specific form of the problem. And then the last thing we might want to notice is that f of x has the same end behavior. Okay, now this is important because what we notice is that if it goes up on one side and then it also goes up on the other side, all right? And as we take a look at the other shape, we'll notice the same thing happens, right? As it goes down on one side, it'll go down on the other side as well. So whenever you have an even degree, like x to the 2nd, x to the 4th, x to the 8th, x to the 10th, x to the 12th, right? If it's even, you're always going to have the same end behavior on both sides for your y values, okay? For this next one here, notice the only thing I did is I made a negative, so a is less than 0, n is still even, right? My exponent is still even. And so what we notice for my end behavior, I'm going to actually just draw it on the graph. So we know here that as x goes to negative infinity, right, as I go left, we know that my y values also go down, right? So as I go left, my values go down. And then over here, as I go to positive infinity, right, as I go to the right, my y values will also go down. So notice that your end behavior with your y values is always going to be the exact same when you have an even degree. All right, some things we notice about the shape. We notice it opens downward. All right, this is because a is negative, a is less than 0. All right, we also know that, again, the higher the degree, the flatter it appears. All right, and then again, we should notice that because it's even, we should notice that f of x has the same end behavior. All right, and then on the next page, we'll talk about when n is odd.